Yep, my name's Peter Harrison. As Guy says, I was the former president of the New Zealand Open Source Society and currently the vice president. Didn't want to necessarily talk about open source as the primary topic today. What I'd like to talk about is the technology of sustainability and how technology will help us in the future achieve a more sustainable future. And I think this is one of my pet projects because I think it's important. It's in fact critical for obviously our future well-being. So what does our future hold? I think there's two important things from the sustainability point of view. There's one obviously is climate change. What effect is climate change going to have on us? And peak oil, which is related to but not the same as climate change, obviously. Okay, so what do we know about climate change? We know that it's probably going to be warming. Okay, we know there's going to be some degree of warming, and we're now measuring warming. So, there's obviously some scientific debate still about how much warming there is going to be in the future, but there doesn't seem to be much scientific. There is a scientific consensus that there is going to be some warming. It is really just a matter of how much. So, the question I'm going to ask today is, well, should we be trying to reverse CO2 emissions? Or should we be trying to develop some kind of technology to be able to cope with the changes in the world? And obviously it would be nice, I think. My thesis is that trying to change CO2 emissions isn't going to produce big enough of a change to avoid the downsides. Okay, so what are these downsides? Well, we can expect increased natural disasters. In fact, I'd go to say that we're not just expecting natural disasters to be increasing, but we're experiencing them right now. There's been increased, just a few weeks ago we had a tornado come through Albany. It's not the first one to come through Albany, but it's by far the largest in, as far as I'm aware, recorded history. Not just through Albany, obviously, but through New Zealand. I don't know of any other tornado that actually created the funnel and the same kinds of effects. So I think we're seeing some changes, although possibly just the very first stages. From a global perspective, it's going to cause a reduction in fresh water, although locally for us that may not be true. We may actually see an increase in New Zealand, but for other countries we're going to see droughts. We're going to see continued effects on countries unable to grow their own food, basically. Which leads into my second point. There's going to be a reduction of arable land, and as a result there might be mass migrations. So that's pretty serious stuff. We're looking at some pretty big changes in the world, not over the next necessarily 5 years or maybe even 10 years, but certainly in the next 20 to 25 years we're going to be seeing some. The other issue we have to deal with, which is related, in fact, to creates an even worse situation for us in terms of food supply. Peak oil means that it's going to be harder for us to extract the remaining oil. It's going to cost more, and as a result, we're going to see some impacts once again on food production. We need oil to be able to produce food in the kinds of efficiencies that we're seeing now. And by efficiencies, I mean creating the volume of it. From an efficiency point of view, per calorie, it's really bad. For every calorie we produce of food, we're wasting 10 calories in terms of oil. Okay, so if you cheese hamburgers or whatever, for every calorie in your cheeseburger, you've got another 10 times that amount that's being burnt in oil and carbon products. Also, it's going to affect the manufacture of plastics and manufacturing processes themselves. So, manufactured items are going to become more expensive. The cargo and transportation is going to become more expensive. So why am I talking about this? Well, I think the real key here is that we're going to have to use our technology to adapt. We need to think smarter. We need to be able to leverage our technology to be able to meet the needs of our population as we face these, well, I'll call it a crisis. In the future it will be. If we run out of oil, we need to find a way to be able to work around and adapt to that challenge. The time to develop the technology is not in 20 years. Okay? In 20 years, by the time we need this technology and by the time it starts to really become critical for us, it will be too late. Now, of course, we are developing new technologies. There's new batteries being invented. I read an article just today about some new batteries being invented. Obviously, the scientists are improving battery capabilities. There's new wind turbines. Obviously, wind turbines have gone up in Wellington. So the technology is being developed for them and being deployed. There's also solar collectors, and there's all kinds of new technology being generated. But if there's any time to be in the technology game and developing new technology around these problems, it's now. Okay, I first want to talk about public transport and electric trains, because it's easy to get into, in the subsequent slide I was talking about electric cars, but the most efficient form of transport publicly is trains. And as you might know, Auckland is committed to developing electric train technology and installing that. And I think this is a great move, not just because it's electric. Well, the benefit of electric is that it means that even though we run it on coal power now, in the future when we develop our renewable infrastructure, it means that we can move that technology to new renewable forms of resources. But even if you don't, even if you do run it on coal, it's still better for the environment, and it still releases less CO2 than if you run petrol-powered cars. Unfortunately, I don't think we're going to be able to get rid of cars. I think there's a certain flexibility with them. Public transport isn't going to be able to get you to where you want to go necessarily. For example, I live in Henderson and need to get to the shore. At the moment, there's just no public transport which can get me there in a timely manner, so cars are probably the best way to do that. And electric cars, although probably not as good as public transport, are the next best thing. Like electric trains, they're going to be able to use the resources that we generate from our natural resources rather than from CO2 emitting technology. Again, even if you run your car on electric power generated by coal, it's still better than if you run it on gasoline.
How can that be if the power plant has got a certain efficiency, there's an efficiency or an energy loss in the transfer, and then in generating, if I'm running on petrol, I've got usually a better efficiency than for the whole chain. And so it basically creates the pollution only somewhere else. But,
now if you look at the efficiency, because the problem is that if you generate electricity and you store it in a car, when you're using an electric car, you only use the electricity when you're actually using it for motive power. Whereas in a car, if you look at any motorway in the mornings, you'll see, I don't know how many thousand cars burning fuel unnecessarily. So, I mean, if you look at the efficiency just while the car's moving, you might be right. But the thing is, a lot of cars, they're not moving at an optimal speed. Using petrol, I mean, for starters, it's only 30% fuel efficient anyway, which is about the same as coal, maybe a bit better actually. But when you look at how efficient it is over the entire journey, things get even worse.
Even when you use hybrid cars that shut down?
No. Actually, yeah, I have a hybrid car, and actually, yeah, hybrids are also. Yep, good point. I think probably a hybrid would be.
Under the bottom line, the hybrids would outbeat a pure electric car in terms of efficiency.
That's a really good question.
Yeah. I mean, I'm an engineer, but I'm originally.
That is actually a good question. And you know, I'm certainly not against hybrids. I think if you can't be all electric, then a hybrid makes sense. In fact, it could even make better sense because you could run your hybrid off of renewable fuel supplies. So for example, if you had a hydrogen hybrid, you have a certain amount of hydrogen in the back, and you could run it. I'm talking about internal combustion.
Or with a fuel cell or something.
Yeah, there is potentially fuel cells as well, but that generates electricity. So,
I mean, with a hybrid, you have a decoupling again of the generation and the power that is used. So you're usually not driving the drivetrain directly. So you do have that decoupling, but you don't have the long storage and transfer.
The price does have a coupling between them. It directly drives the wheels. Other ones like the Tesla will have a separate ICE generating electricity, and the main electric motor drives the car and doesn't have any other drivetrain.
One of the arguments against the hybrids, though, is that you look at the whole cradle engineering model. You're building a car with two engines, so the energy expended in building them and in destroying them actually has to be factored in the whole equation.
That's also been used against electric cars. And the thing is, well, at least in terms of fuel, if you're generating the amount of energy needed to be able to create a litre of petrol is above actually the amount of energy you get out of the petrol itself. So it's when you look at the efficiency equation, you're not just looking at how much you release from the petrol itself, but how much did you release from the fact that you've sucked it out of the ground in Arabia, shipped it across the sea, distributed it through, and finally it's got into the petrol station. All of that process takes energy and thus will cause emissions in some form or another.
And then I guess if we look from a technology point of view, the internal combustion engine is notably wasteful. We've had it for a number of years. We seem to be quite comfortable. There's got to be something there.
Well, I mean, there's a lot of people who were working on internal combustion engines, but to be honest, I think the electric car, I mean, obviously we're not quite there in terms of technology yet. That's kind of why I'm talking about it, is because getting into this kind of research, not just the physical stuff, right? Because I was getting to the point of talking about how software interacts with these systems. Now, if you look at a Prius, for example, most of the what makes a Prius, or for that matter, any one of the modern hybrid electric vehicles, is it's really the software control of these systems which really makes it possible. 20 or 30 years ago, you would have needed a damn big computer to be able to drive all of the electronics, to be able to work out when to engage one drive or the other drive. So now the electronics has got to the point where you can have relatively smart systems be able to manage that. And it's not the only place, in fact. Software is being used all over the place in terms of being able to control the efficiency of devices. And yeah, electric cars are a great example.